Okay, let me state the limit comparison test one more time. Okay, what it says is it doesn't need many conditions. Okay, it says that if an is positive and bn is positive and limit of an divided by bn is equals to L, where is L is finite and positive, then the summation an, the series of an and series of bn, they converge and diverge together. Meaning, if the series of an converge, this series converge, bn converge. Series of an diverge, then the series of bn diverge. That's what it says. Okay, so that is the limit comparison test. Now, so we always assume whatever given as an. So this is an there. Okay. Now we will assume bn. Let us take bn is equals to, usually what you take is, you see that? Just take the highest degree term in the numerator and highest degree term in the denominator and take the ratio, just write in the lowest term. You see that? You see the degree of the top is 1, degree of the bottom is 2. So if you cancel that, you will get 1 over n. You just think that way. So let us say that bn is 1 over n. Usually we choose bn that way. Okay, now, so what is limit n tends to infinity an over bn? That will be limit n tends to infinity. An is n over n squared plus 1. bn is 1 over n, right? So this can be written as limit n tends to infinity, right? And then you can write n squared over n squared plus 1, because you see it is like n over n squared plus 1 times n over 1. That's what it becomes, right? Now, what is this limit? So you can use L'Hopital's rule, because it is infinity over infinity format, right? If you use L'Hopital's rule 2 times, then you will get that as 1. Okay, so the limit of this is 1, which is finite and positive. Now what we can say, the series, the given series and then the series bn, either both converge or diverge. But we know that bn diverge by what? You can write but summation of bn, n equals to 1 through infinity, equals to summation of 1 through infinity 1 over n, diverge. Why? P integral test or P series test, diverge by P series, right? Because it is 1 over n to the P, where P is 1. If P is greater than 1, it converges. If P is less than or equals to 1, it diverges by P series. Hence this series, summation 1 through infinity n over n squared plus 1 diverges. Okay, that's what we got. Now let's do number 2. So this is an, definitely this is an, right? What should be bn? Let bn is equals to, it is 1 over n again, because there is a root and then n square. Okay, I'm not just considering all the terms, I'm just picking the highest degree term of the numerator and the highest degree term of the denominator, and then with the root, that will be 1 over n. Now what we do? Exactly the same way. Now find out the limit. We will use the limit comparison test. Okay, so limit, so diverge by P series, hence this diverges by limit comparison test. Okay, let me write down that, I didn't have space there, by limit comparison test. Okay, so limit n tends to infinity on the second problem. Let's do an over bn. That can be written as an is 1 over root n squared plus 1, right? And then divided by bn is 1 over n. This can be written as limit n tends to infinity n over root under n squared plus 1. Okay, now take n out from the denominator, because it is in the basically it is infinity over infinity form. So if you take n outside, what do you get? Limit n tends to infinity n over, take n, what do you get is 1 plus 1 over n squared. Cancel that. If you take n tends to infinity, this will be 0, so basically it is 1. Okay, also summation of 1 through infinity 1 over n, which is bn, diverges by what test? P series test again. P series test. Hence by the limit comparison test. Okay, because either both of them converge together or diverge together, because the limit of the ratio of the nth terms of an and bn is a finite positive number. Okay, summation 1 through infinity 1 over root under n square plus 1 also diverges. RGES, diverges. Okay, so how about 3? What should be Bn? So this is definitely An. Okay, this one is definitely An, right? An. What should be the Bn then? Let's look at that. What is the highest degree term here? It is 2n square. What is the highest degree term here? It is 3n to the 5th. If you do that, then you basically see n square over n to the 5. So I want to write 1 over n to the cube. You see that? You don't have to worry about the 2 and 3, the coefficient. I mean, if you want to, you can do 2 over 3n cubed. You can definitely do that, no problem, okay? But you don't have to write the coefficient. You just write the exponent. Highest exponent on the top is 2, highest exponent on the bottom is 5. If you cancel that, you will get 1 over n to the 3rd, okay? So you can assume Bn like that, okay guys? Now, what I'm going to do is trying to take the limit n tends to infinity an over bn equals to what? You get 2n squared minus 1 over 3n to the 5th plus 2n plus 1 times, you can write n cubed over 1, n cubed over 1. How? Because it is divided by bn. It should be in the denominator of this fraction. So when you write in the product form, then you can write n cubed over 1, okay? So what do you get there then? So let us write down 2n to the 5 minus n to the cubed divided by 3n to the 5 plus 2n plus 1. Okay, now take n to the 5 out. What do you get? You get n to the, when you take n to the 5 out, you will get 2/3 and then n to the 5 over. So this will look like that. N to the 5 out. What do you get? 2 minus n to the cubed over n to the 5. Okay, and then in the denominator, n to the 5 out, 3 plus 2n over n to the 5 plus 1 over n to the 5. That's what you get. Okay, now when you take the limit n tends to infinity, that will cancel out, and when you take the limit n tends to infinity, this term will be go to 0. Okay, that term will go to 0. You see that? So this term will go to 0, and then this term will go to 0. This term will, why? Because there is n to the 5 in the denominator, and there is n to the cube in the numerator. So if you divide, you will get 1 over n square. So when n tends to infinity, this term go to 0, that term. So basically what we got is 2/3, right? That is 2/3, which is finite and positive. Okay, so also summation of bn 1 through infinity 1 over n cube converges by what? By p series, right? Because n to the p is greater than 1 by p series. So this series converges. Since the limit of the ratio is a finite number, finite and positive number, and since this series bn converges, then the an should converge, the series of an. Hence by limit comparison test, summation of n equals to 1 through infinity 2n squared minus 1 over 3n to the 5 plus 2n plus 1 converges. Okay, that's what you got. All right. Next example here is n equals to 1 through infinity. Okay, n equals to 1 through infinity, and then n to the k minus 1 over n to the k plus 1. You see that? So this is definitely an. This is an. Okay, let me write down that an. Whew. So that one is an. And how do I take bn? You see that? What is the highest exponent of n in the top is n to the k minus 1. On the bottom, n to the k. If you take that ratio, you will get 1 over n. That is b. Okay. Now again take the limit n tends to infinity an over bn. What do you get? You get n to the k minus 1 over n to the k plus 1 times n. So that will basically, you will get n to the k over n to the k plus 1. And if you take the limit, you will get basically 1 here when you take the limit. Okay, because you can factor out n to the k on the denominator, and you will get 1 plus 1 over n to the k if you take that out and cancel with n to the k in the numerator. And summation of 1 over n, the summation of the bn 1 through infinity, diverges by what? Diverges by p series. by the P series test that diverge. Hence by limit comparison test, the series summation n equals to 1 through infinity n to the k minus 1 over n to the k plus 1 diverge. So the basic idea is try to find out Bn. Okay, try to find out Bn. So Bn should be in the form of 1 over n to the k. Then it is easy to tell whether it is converge or diverge. Okay, so the Bn, but how do I find out Bn then? And again, this method may not be applicable to all types of problem. If there is a like polynomial or algebraic expression on the top and bottom, okay, on the top there was n here, on the bottom n squared plus 1. You see there is 1 root under n squared plus 1 like that. If there is this type of expression on the top and bottom, then this test is applicable. But if there is like log or exponential like that, then this test may not be very useful. Okay, so far we learned the divergence test, nth term divergence test, geometric series test, P series test, telescopic series test, integral test, comparison test, and limit comparison test. That's that many tests we learned so far. Okay, now in the exam you can use any type of test you know. Okay, so if you know one test, because some of the problem can be done by using more than one test, more than one formula. Some of the tests it is easier with one test than the other. Okay, it depends on the nature of the problem. Okay, on these following examples, what I'm trying to do here is basically giving you some series. Okay, and then you will use any series that you want. Okay, n squared plus 1 square. Okay, so it says use any test for convergence or divergence of these 3 examples. Okay guys, so let us see, what do you think? What test can we use for that? So what I would use is, I would use like this. Let's say this is an, let's say bn is equals to 1 over 5 to the n. So which series is bigger? Is the series of bn bigger or series of an bigger there? So here you can write, so basically this is bigger because it has a smaller denominator, right? This has plus 1, this has just 5 to the n. Okay, so here 0 is less or equals to an is less or equals to bn. Let me write just less than. Okay, so this is the case, and summation of n equals to 1 through infinity 1 over 5 to the n is a geometric series, GS, geometric series with r equals to 1 over 5, which is less than 1. So summation of bn 1 through infinity converges, right? You see that bn has bigger terms. Bn has bigger terms than an, and the bigger series converge. Hence by comparison test, summation of n equals to 1 through infinity 1 over 5 to the n plus 1 converges. Okay, that's how we get it. Right, so we are just trying to see whether it converges or diverges here. Okay, number 6, I think on this problem you can use the divergence test. So because what it says in the divergence test is, if the nth term of the series does not go to 0, does not go to 0 when n tends to infinity, the an is not 0, then the series diverges. Okay, so we can apply that thing here. Let me do here. So here a sub n, that is the nth term, okay, is 2n over 3n minus 2. What is the limit of that? Limit n tends to infinity an is equals to limit n tends to infinity 2n over 3n minus 2. So it is infinity over infinity. You can use L'Hopital's rule. So you get 2 over 3. If you find the derivative of the top, you get 2. Derivative of the bottom is 3. So this is not 0, right? This is not 0. Hence by divergence test, the series diverges. Because if it is not 0, if the limit of the nth term is not 0, then the series always diverges. Okay, so the final example of section 9.4, I have series of 1 through infinity n over n square plus 1. Do you think this converges or diverges? I think we can use integral test, right? You see that this series is positive and then continuous and then non-decreasing. If you find out the derivative, you will get negative. Okay, so we can use the integral test. So you can say continuous, non-negative, and then if you find out if you find out the derivative, okay, and then the derivative will be negative if you try to find out the derivative of x over x squared plus 1 whole square. Okay, and then decreasing. I think we have done this example in the last video. Okay, since this is the case, then this series and then integral converge or diverge together. Okay, since this is the case, then this series and this integral 1 through infinity n over n square plus 1 square converge or diverge together. Now you can use more than one method. I think you can use the method that you can. I think you can use the limit comparison test on that too if you want to. Okay, the limit comparison test also works here. Then by the P series test, because by the P series this will converge. Okay, so how do I know that? Is because if you just do that 1 through infinity n over n square plus 1 square. Okay, if you do that, you can add 1 over 2, 1 through infinity 2n over n square plus 1 square dn, or you can write x there. Okay, not a problem. Let us do x. I think x is easier than n there. Okay, so you can use x square, x over x square plus 1, and then 1 through infinity you can do 2x over x square plus 1 square. If you set that x square plus 1 as u, then you will get that as 1/2. Okay, and then what will be that? That will be, if you said like what I was saying was x square plus 1 equals to u. So what will be the limit? 2x dx will be du, and the limit will be when x is 1 it will be 2, when x is infinity, so 2 to infinity, right? That's what you will get here, 2 through infinity. If you you can see the more details in the last video there. We have done this problem. So you will get 1 over u square du. You see that? This integral converges by the P integral test, right? Because u to the P, so P is greater than 1. So converge by the P integral test. Okay, this converges because u to the 2. This is improper integral with the exponent greater than 1. Okay, so since this converges, then this limit converges. Since as this integral converges means the series converges. Hence by integral test, the series summation n equals to 1 through infinity n over n square plus 1 square converges. Okay, so the idea here is there are several tests that we are learning so far, and we'll learn some more tests again in the next video. Okay, so the idea here is some of the test is applicable in some problems, not all the problems. Okay, so for some problems one test is easier than the other test. So you should whenever you practice more problem, then you will know that which test is applicable for this problem. Okay, so you can do that. Alright guys, so this is how we use the comparison test and limit comparison test. Thank you.